All right, so I would like to introduce our speaker, Dr. Leesa Souto. She is the Executive Director of the Marine Resources Council, and she received her doctorate from University of Central Florida with an expertise in urban ecology that links human geography, structures, and behaviors to water quality impacts. Her research focuses on groundwater impacts to the lagoon, muck management strategies, fertilizer, and alternative landscapes such as LID, low impact development. Dr. Leesa Souto has over 20 years of experience working to improve Florida's water quality and has worked with numerous agencies. She loves the water and exploring new ecosystems in Florida and around the world. So without further ado, I will turn it over to Dr. Leesa Souto.
Hey, everybody. All right. Thank you, Nicole, for that introduction. Thank you all out there in the virtual world for being here today. A blustery day here in Brevard County, so it's a good day to be inside, nice and cozy and warm, hearing about groundwater pollution. So thank you for participating today. Thank you for your questions in advance, and thank you for your interest. My name is Leesa Souto. I'm the Executive Director of MRC. I have extensive background in water pollution here in the state of Florida, having worked with the state, with local government here in Brevard County, the University of Central Florida Stormwater Management Academy, and Midwest Research Institute, and then more recently here with the Marine Resources Council. So my background really has been extensive in terms of looking for, toxins and petroleum in groundwater, to trying to reduce nitrogen in stormwater. So I'll talk a little bit about those different sources and what we found with our study. So I gotta, of course, include a big shout out to our partners, Applied Ecology, my friend and colleague, Dr. Claudia Listapat, and her amazing team at Applied Ecology worked with us cooperatively on this. They continue to take the lead to implement the monitoring effort, and I'll talk more about how we're continuing to monitor in order to evaluate project success. So this is a great project. It's funded by Brevard County. Initially it was funded through a legislative appropriation by the state of Florida that went through the Florida Department of Environmental Protection. And then it's been extended to really evaluate, to help prioritize and address the need to retrofit and improve communities on septic systems, communities with leaking infrastructure, and community wastewater treatment facilities that can be updated. So thank you to Brevard County for the support and the technical guidance and everything that you've done through the Save Our Indian River Lagoon plan to save our Indian River Lagoon. So with that, I will provide a brief overview. It's not advancing, of what the lagoon is. So the Indian River Lagoon, just in case there are some newbies out there that just moved to town, the Indian River Lagoon is not just that thing that you're driving over to go over to the beach side. It's actually a third of Florida's east coast, 156 miles long. It stretches from Volusia County all the way down to the Palm Beach County border. It was designated an estuary of national significance. One of the main reasons that it got that was because it was determined to be the most biodiverse estuary in the United States, with over 3,500 species of plants and animals that use it as habitat. The lagoon is also a very important economic driver, bringing in almost $8 billion annually to our regional economy. So it's we're so fortunate to live with this amazing place in our backyard. It's important as a resource for not only our community, but our state. Used to be the largest shell fishery in Florida, and we've lost all of that. About 50 endangered species live and reside in the lagoon, and we're doing everything we can to try to protect the lagoon, not only for our own benefit, but for the benefit of the amazing life that it has. The lagoon, and anybody that's been here, you don't have to have lived here for very long to know the lagoon is changing, and it's not changing for the better. We've been experiencing these algal blooms. We've experienced some megalithic fish kills. We've got algae of all different colors. The brown tide, the Oreombris lagunensis alga was first discovered here in the lagoon in 2011. It never had been found in the lagoon before. Now it's pretty much something that blooms every year. We've got the cyanobacteria blooms, the blue-green algae, different types of blue-green algae blooming in different parts of the lagoon. We've had red tides, we've had green tides, we have blue, mocha tide, we've got brown tide, we've got every color under the sun of algae blooming. And then when those algae all die, that's when the biological oxygen demand in the water reduces the dissolved oxygen to the extent that the fish merely suffocate. It would be like, if 90% of the oxygen went out of the room that you're sitting in right now, how would you do? So a lot of the fish, if they're in an area with absolutely no oxygen, they just suffocate, they'll gasp at the surface and die. And that's what we experienced here a few years ago in 2016, had the huge fish kill, got international attention, and that things here are going, getting bad and going to the worst. So, we've had unusual marine mammal mortality events. We're experiencing one right now, manatee and dolphin deaths, indicating that, we're looking at an estuary at risk. And this came from the New York Times in 2013. We got national and international attention back then, which is not good. It's not good for business. It's not good for our communities' quality of life, and it's certainly not good for the creatures that are living in the Indian River Lagoon. So what are we going to do about that? Well, we need to think about putting the lagoon on a diet, as my friend Dr. John Windsor would say. This system has received too many nutrients. The nutrients I'm talking about are nitrogen and phosphorus. These are pretty much the building blocks of life. They're everywhere. Nitrogen rains out of the sky, literally. It makes up our body's cell count. It's what makes proteins, and they're kind of the building blocks of life. So everything is made out of them. So when things break down, when things die and decay, it's going to release nitrogen and phosphorus, for example. So all of these, what happens in coastal areas, and particularly in our Indian River Lagoon, is that nitrogen and phosphorus that are released from the landscape enter into a canal or into a river, and then they all, of course, drain to the coast. So we know we drain Florida to the coast. If it's not the East Coast, it's the West Coast. The entire state is drained through canals and tributaries so that we can build our houses on it. Otherwise, it'd be pretty swampy. So what's happened is all of that drainage, all of that contaminated runoff and groundwater is going to our coast and concentrating there, especially in our Indian River Lagoon, where we just don't have the flushing that they get, for example, in Tampa Bay, where they've got a large opening, they've got a lot of circulation and flushing in Tampa Bay. We do not. We have a lagoon. By definition, a lagoon is cut off from the ocean by a barrier. It could be a reef. In our case, it's the barrier island that stretches all the way along Florida's east coast. The intercoastal waterway runs right through the middle of the Indian River Lagoon, but there's really not too many places to get out of the lagoon into the ocean, and therefore there's not a lot of flushing that occurs. So what goes into the lagoon, especially up here in the north end, stays in the lagoon, and those nutrients are getting more and more concentrated. They're also, we'll talk more about the nutrient dynamics later, but so nutrients feed us, they feed plants, and they feed algae. So with these increasing nutrient concentrations, and really the interesting ratio in nitrogen to phosphorus changing over time has been feeding algal blooms. We've got state agencies now studying the different types of algae and where they're coming from and how they're sustaining in the system, trying to get a better handle on how do we break the cycle of, we've got existing nitrogen and phosphorus in the system that's there. Some of it falls to the bottom as muck, where it leaches back up into the water column. The algae eats that up, blooms. When the algae dies, what does it do? It releases all that nitrogen and phosphorus back into the water column, and it becomes this cycle that just goes on and on. Like down here, can they see my cursor? So down here, you can see the cycle, the nutrient cycling they call it, but this is the runoff, excess nitrogen and phosphorus, the algal blooms, some of it falls to the bottom and makes muck. We got to get the muck out. And then there's this cycling. We got to break the cycle. When this dies, it creates that biological oxygen demand of the bacteria breaking down all of that algae, all those algae into their components. That's when the fish kills occur. So O2 drops, oxygen drops in the water column, fish need oxygen, and they suffocate. So where are all these nutrients coming from? This is a pie chart, a series of pie charts that were created by Brevard County, really just a rough estimate, which shows that most of this nitrogen and phosphorus, where the sources are coming from. The nice thing about this is this little 1%. See, those are point sources. Those would be things like industrial waste pipes are dumping into the lagoon, wastewater treatment, outfalls dumping into the lagoon. So those have been, for the most part, minimalized. So that's a good thing. But the bad part of that is it's a lot easier to deal with point sources than it is to deal with non-point sources. So everything else in the pie chart is a non-point source, and non-point sources are kind of difficult to deal with, especially when they're raining out of the sky. Like this percentage, 15% of the nitrogen going into the Indian River Lagoon is atmospherically derived. It's coming from the atmosphere. It's literally raining out of the sky. So how do we deal with that? We stop driving our cars, really, because that's one of the main fuel combustion engines are one of the main sources for NOx, for nitrogen gas to be released in the atmosphere. So when we solve climate change, we're going to solve this problem of atmospheric deposition also. The green section is stormwater runoff. So that's what's coming in across the land. In that picture, it would have been the arrow coming from the land. And then the black part here, I'm saving the best for last. The black part here is muck, and that you can see how much of the nutrients is coming out of the muck that's in the bottom of the lagoon. This is a legacy load of nutrients sitting down there on the bottom, being gross, like you don't want to step in it. And also it smothers the benthos, it prevents seagrasses from coming back, and it off gases nitrogen and phosphorus back into the water column. As long as it's there, it's going to be a pollution problem. Lastly, what we're going to be talking about today is the groundwater. So trying to get a handle of just how much nutrients are coming in through groundwater, which areas of the county are worse than others in terms of the amount of nutrients coming from those areas, and how do we prioritize and affect a change in this source of nutrients coming from groundwater. So what is groundwater? Groundwater is water in the ground. I know that's a silly answer, but it's an important resource here in Florida. The groundwater, if you've come from somewhere else in the country, you might think of groundwater as being like 60 feet down, 100 feet down, 300 feet down. Nope. Here in Brevard County, the groundwater is about 9 feet down. On a deep day, I think the groundwater in my yard's about 4 feet down. It's very close to the surface. You start digging a hole anywhere along the coast and you're probably going to hit groundwater. It's interesting, you know, the elevation, the changes in topography here tend to be like ancient sand dunes. So very, very porous types of soil. So whatever you put on the top is going to eventually filter its way through the ground and end up in the aquifer. Whether there's enough time between that, you know, that it hits the ground and it gets to the aquifer, to the groundwater, is going to depend how contaminated that, you know, the groundwater is going to get. Another thing about groundwater is most Floridians drink groundwater. We get most of our drinking water from groundwater, which is why Florida has put into place a lot of groundwater protection programs, because this is where a lot of Floridians are getting their drinking water. Even municipal wells, you know, Titusville has a municipal well field, Palm Bay has a municipal well field, Melbourne has a municipal well field. And those wells, like this one right here, they're tapping into groundwater. This would be a deep well. Some homes have their own drinking wells, and they typically don't go as deep. So we just need to be aware that groundwater is a commodity. It's something that we rely on to drink. We need to drink fresh, clean water, and we should not be contaminating it. And it is very susceptible to contamination because it's so close to the surface. The two areas we're going to talk about today are the sewer lines up here. So sanitary sewer lines, people, you know, forget that they exist, but they're down there, out of sight, out of mind, you know, pumping our raw sewage away from our homes into the sanitary treatment plants, and they leak. So we need to keep an eye on what they're doing. And then the septic tanks that people have in their individual homes. The objectives of the study were really to understand better the groundwater sources, which ones are the most contaminating, which types of communities are the most contaminating to groundwater, where are these sources, and can we prioritize projects based on their potential for contaminating groundwater. Another objective was to refine existing pollutant load models. So trying to refine there's a model that has been done to determine the nitrogen and phosphorus loads that are allowed to go into the Indian River Lagoon through the total maximum daily load, or TMDL program. That model used a single number to assess how much groundwater was going into the lagoon. And so we're providing some updated numbers to update the model. We also did a representative survey of septic tank owners to understand what they're doing in terms of maintaining and inspecting their septic tanks. We're not going to talk about that today, but it may be a future presentation. We're ultimately want to inform management efforts and evaluate their effectiveness. And that's where Brevard County is most interested in continuing to fund this research is, we want to know where we can put our money to make the biggest bang for the buck, and we want to make sure that it's working. So that's important part. The study includes multiple regions. We put in 45 wells in really 5 different areas of the county. Titusville, Turkey Creek, Suntree, Merritt Island, and then our beaches, we combined into the beaches, Melbourne Beach and Satellite Beach. So we wanted to make sure we picked some regions that were on the mainland, some regions that were on the Barrier Island, and then we've got one up there in Merritt Island. We were trying to find in each one of those different regions a setup like this in Turkey Creek. This is the only place we got such a perfect setup where we had our 4 different treatment areas in proximity to each other along the receiving waterway. So the treatments that we're comparing in the study include a subdivision that is on reuse water or reclaimed water. And this is water that is discharged from the wastewater treatment plant, which is actually right up in here. Right in here is the wastewater treatment plant. And it's used for irrigation. So it's almost like years ago, we thought that this was a solution to help protect our drinking, our potable water sources. And it was also a final treatment for wastewater, was that wastewater treatment facilities could be permitted to discharge through irrigation lines their final scrubbed discharged wastewater. So it's that non-potable water that you see signs everywhere. Don't touch the fountain. Don't drink out of the hose. It's that irrigation water. So that's one community type, reuse. Second community type are septic tank communities, a community that's all on septic tanks. I think that one speaks for itself. Third community type are sewered areas. These are people who have sewer lines that are taking their sewage to the wastewater treatment facility, but they do not have the reclaimed water irrigation. And then lastly, of course, we wanted to have a quasi-control a natural area to compare the 3 different types of residential communities to a natural area to better understand the difference in just background concentrations, what we would expect to see, and what we're seeing in our 3 community types. In each of those different regions, we tried to have one of each of these, but it wasn't possible in all of them. Next step was we had to go and recruit homeowners, and if you are one of these homeowners, thank you. We couldn't have done the study without you, and we just had a party to thank them this past Saturday. But they had to allow us access to their property. So we were working in homeowners' yards on personal property, installing wells using a track-loaded well geoprobe device, like the one in the picture here, doing a soil core first to identify and understand the soil type, and then installing a screened, encased well. 10 foot of well screening for those of you who are interested about that. Sampling equipment, we went out and sampled every month these wells, 45 wells. This is the equipment that we used. We took water levels, we took physical parameters, we made sure that these wells were properly purged and stabilized before grabbing sample, and everything was documented accurately. So what are we looking for? We're looking for these 2 nutrients, in nitrogen and phosphorus. And basically nitrogen comes in many, many forms, but what we're looking at to compare are organic and inorganic. So the organic nitrogen that you'll see in the tables and charts includes total KJELDAHL nitrogen, TKN, which is a measure of total kind of organic nitrogen. It includes the parameter ammonium. And this is what you would typically see coming out of a decayed product. So animal waste, plant decay, bacteria in the soil, fungus, anything that's breaking down that's organic, you would expect to see it as a measure of either TKN or ammonia, depending on where it is in its breakdown cycle. Inorganic nitrogen that we're looking for is nitrate and nitrite, which is NOx. And that comes from, this is what we would see from atmospheric deposition. We would see it from commercial fertilizers or fertilizers that are atmospherically derived, which is most of them. This is where what cars are going to be, you know, it's going to come out of the atmosphere from combustion engine releases of nitrogen and nitrification. So because this nitrification occurs, these two things, so when organic breaks down, it breaks down into inorganic. So it's a complicating feature of trying to understand source dynamics, because you have to understand where things are in the nitrification, denitrification process. It's not as simple as if you find this, you know that it's coming from one of these sources, because it could be coming from one of these sources and it's just broken down. Total nitrogen is the combination of these two. That's what mostly I'm going to talk about today, because it's just simpler that way. And then the two phosphorus components we're going to talk about today are the biological phosphorus, which is this orthophosphate, it's called, and then total phosphorus, which is all forms of phosphorus. All right, so jumping right into results now. So let me just, again, because you're going to look at these and you're going to try to remember TKN, NH3, organic nitrogen, NOx is inorganic, and then TN is both of them, okay? So the first set of results is the total nitrogen, and the graph that you're looking at is the monthly average for the 4 different treatment types. So, and the colors that you see are going to stay consistent throughout the presentation. Green is always the natural area, and you can see it bouncing along the bottom there. So total nitrogen would naturally be very low. The purple is the sewer, which as soon as you add people to the landscape, you've just increased your nitrogen in groundwater by 3 to 4 times. And then it just goes up from there. Those two, the red and the blue bouncing along together there, are our reclaimed communities and our septic communities. So this is all of the regions combined over the years of the project. I don't know how many months are there. I don't have my glasses on, but there are quite a few months of data. The other graph that you see there is a box plot of total nitrogen results. And this is helpful because it lets you visualize the variation in the data. For example, that very first bar that you barely can see down here is the natural. And this, what this tells you very quickly is kind of the same thing this tells you. There's not much variation in the concentrations of total nitrogen in our natural communities. This is the reclaimed or reuse communities, and you can see tremendous variation in total nitrogen. This line is going to be all of the data, the variation of the data. And then this is going to be the bulk of the data. And the dot right here is the median. We're using medians for central tendencies in the box plots. So it kind of gives you an idea of just looking at total nitrogen that these two bars are very similar. This is the reclaimed and the septic. Tremendous variation, and that their medians are not terribly different. And then this one, of course, has very little variation. And then our sewer community over here is relatively low. The other thing I want to point out to you is when you're looking at these graphs, pay attention to the y-axis, because this axis is going to change from time to time, especially between nitrogen and phosphorus. That you'll see, you know, this one goes up over 10 milligrams per liter. 10 is the drinking water standard for nitrate. So this is total nitrogen. We don't know if this is nitrate or not, but this is going well over the drinking water standard for nitrate. Just to give you an idea of, these numbers are very, very high for having nitrogen in groundwater. We certainly don't want to be drinking this. Organic nitrogen, this is that TKN, which includes ammonia. So it's total organic nitrogen. So it's a reflection of this, but it looks different, doesn't it? And we'll talk more about this later, what communities have which kind of nitrogen, which ones have organic and which ones have inorganic. But here again, down here at the bottom, notice that we're looking at a totally, almost a third of the milligrams per liter. Look at the numbers here on the y-axis. So this is much, much lower than what we were looking at for total nitrogen. TKN, septic communities is highest, and then the Seward community is the next, and the reclaim community is much less organic nitrogen than inorganic nitrogen. Oop, I gave something away. And then, the natural, this is, these are still very low numbers compared to what we saw in the other chart. But this is what we would expect to see. So this is the background of organic nitrogen we would expect to see in a natural area. You can see that it's much, 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 much lower. This argument of, oh, it's not us, it's the leaf debris. No, it's us. We're the polluters, not the trees. Okay, so over here, we've got same thing with the box plot. Again, the line gives you an idea of the extent of variability. So septic community is very, very variable. I always loved saying that. And you can see it by looking at the lines. And then our natural control, not as much variation. And then the sewer community is very curious. So the first quarterly report that we wrote, we were at Florida Tech. We had a review committee, and we explained we were getting really high numbers in the sewer community, and we suggested that it could be that it was leaking sewer lines, and he didn't agree. He didn't agree with us. He thought it could be something natural, but no. So anyway, going on. So total KJELDAHL nitrogen, and next one is that inorganic. So this is kind of a different monster. And remember that organic turns into inorganic, so it's not as easy as it's coming from an inorganic source. But what's interesting, again, super, super low levels of nitrate in natural areas, super, super low levels of nitrite in the lagoon or in Turkey Creek. It's the inorganic one is not the one that makes up most of the nutrient contamination in the world. It's the organic kind. The inorganic one, when you find it, like I said, it's either on its way to being denitrified and turned back into N2 gas, so it's going through a process, or it came from a source that was atmospherically derived. So we've got our natural area very low, sewered area very low, and then these nitrate values among reclaimed and septic kind of go up and down here in the 4 to 8. I don't have my glasses on. I'm like, I think that's an 8 parts per million. So milligrams per liter. So, it's getting up here. These are averages in the chart. Over here, we've got medians. And you can see again with the reuse community that we've had some very, very, very high nitrite numbers, and a lot of variability with nitrite in the reuse community. And you can look at this, it doesn't even exist. There's no variability. There's really no nitrite in natural community. Septic more, and then the sewer also, we did not see much of the inorganic nitrogen. And that's, we kind of expect to see the organic nitrogen kind of coming in here. So here's a comparison just quickly between inorganic versus organic in our 4 different types of treatments. The organic is the light blue and the greenish color. So ammonia is part of organic. So this has them teased apart in these graphs. The orange would be our inorganic. So it's interesting that reclaimed is mostly inorganic and septic is mostly organic, which is kind of what we expected to see. Well, it was, we were curious about the sewer, actually. We're like, what are we seeing here? Are we seeing, organic? Or are we seeing inorganic? Are we seeing fertilizer? Or are we seeing, sewage? That's for another day. Phosphorus. Okay, so I really like speaking in front of a group because I can see people's faces better. But I can imagine some of you have already figured out there's something curious going on here with this total phosphorus graph over time. Everybody's down here. There's not a lot of phosphorus. Septic, it totally, tells the story of phosphorus in groundwater, and look at this increase. So if we were to draw a line here, I'm guessing this is a significant increase in phosphorus that occurred And when we first saw it, we thought, oh, it's COVID. It's the COVID time. Everybody's home, eating and not going out much. But this is well before the COVID time. This is, I don't know when, I think it's August 2019. Thank you very much. Where we started to see this trend going up and up and up and up and up. And the other, and we've seen a similar trend in the lagoon. So what is causing this release of phosphorus? Or is it, is it an external thing? Is it because more people are staying home, or is it that there's something in the soil that's not binding the phosphorus as much? Phosphorus clings to soil. It's something is causing it to release more. We're going to investigate that more. So box plot tells the story of this incredible variation in the septic community. Not much difference. I mean, you can almost look at this and tell these are not going to be significantly different, but this one probably is. So so we've got medians, and then just looking at, you notice the scale here. Total phosphorus is in much lower concentrations in the environment than nitrogen. So this is the biologically available form, ortho-P as we call it, orthophosphate, and then we're doing the same exercise, but look at this with septic tanks still. So we've got this biologically available trend. It did drop. This actually looks like a data error or a laboratory error, but a trend line that would basically going up and up and up. Interesting. So we need to, the more science you do, the more questions you have. I swear, it's like it brings up more questions sometimes, and the next series of charts, so these are a little different. These are just comparing those box plots that you guys are all familiar with now across the community types. So these are all of our sewer communities in the different regions. So we have sewer communities in 5 of our regions, and you're looking at them, across from left to right. That's the Beaches region, Merritt Island, the Suntree Vieira region, Titusville, and Turkey Creek. And this is the sewer communities. We started in Turkey Creek with the study as a pilot project. And when we saw the numbers we were getting in Turkey Creek, we were horrified. We're like, oh my gosh, it's not just a septic tank community issue. We're going to have to retrofit all the sewer communities also. Well, we're not going to have to retrofit all of them, because you can see that some of them are much lower than this one. We just happen to start in an area where we really suspect we've got leaking infrastructure, whether it's the lines going down the street or the laterals coming from the house to the street. We're not sure about, but this is a clear indication of something going on specifically in Turkey Creek, and it gives you a good argument for why Turkey Creek should be selected as a project to be investigated for retrofit upgrades or sewer line improvements. So the purpose of this is to give the county and others ideas of where they really need to be prioritizing. So this is our septic communities. In 4 regions, we were able to install wells in septic communities. So again, from left to right, we've got the Beaches, Merritt Island, the Suntree Vieira, and Turkey Creek again. And you can see, all these medians are, not too far away from each other, but some variation here, some variation in the Beaches, a lot of overall, a lot of variation in the Beaches. And I'm sure has a lot to do with their soils, but so the difference in septic communities, not a lot. Oh, let me show you. So notice the milligrams per liter. I'm pointing at it with my finger, like you can see, but you can't. So notice that this one goes from 0 to 20. This one goes from 0 to 5. So sewer communities have a lot less nitrogen overall than septic communities by an order of magnitude, right? Or four times, not an order of magnitude. So here again, we're going back to our scale of 20 for our reclaimed communities. So this is nitrogen, and it's mostly nitrate, remember? And again, Turkey Creek, huge variation, going up well over 20 milligrams per liter in some cases. Titusville came in second, and then the Beaches and the Suntree Vieira community. So these are communities that have that reclaimed water for irrigation, and it is contributing substantially to groundwater pollution. Phosphorus, Turkey Creek, this is our sewer communities. So Turkey Creek again, Merritt Island has an outlier or some unusual high numbers here. And then Titusville, Beaches, and then Suntree came in last for phosphorus concentrations, box plots, and Seward communities. In septic communities, oh, let me show you the difference in the scale here. So phosphorus goes up to 0.7, and here it goes up to 4 in septic communities. So, again, you're looking at a whole different scale of concentrations in the septic communities. Not a lot of difference between them. This is Beaches, Merritt Island, Suntree, and Turkey Creek. And then our reclaimed communities, the Beaches takes the cake here in terms of phosphorus, but notice we're back to that scale. That's lower numbers again. But what's really curious about the Beaches is we would expect to see phosphorus coming out of the soils there. So this might be an artifact. It might be an indication that it's coming out of the soils. Okay, so what did we learn? We learned that really for reclaimed and septic, there's not any difference. There's no statistically significant difference in total nitrogen coming out of those two types of communities. Different forms. So what we're getting from these reclaimed communities is that inorganic form of nitrate or nitrite. And what we're getting from the septic communities is an organic form. But as far as total nitrogen, which is what they use to calculate the TMDL, which they use to calculate calculate the soil effectiveness of the soil plan, the Save Our Indian River Lagoon tax project plan, it's total nitrogen. So the total nitrogen for those two communities is not significantly different. This increase in phosphorus over time is very, very interesting, and we're going to pursue that further, particularly that we saw that increase in the septic communities. It was visibly obvious, and I'm sure statistically we're going to see a significance in that trend line. So, what's up with that? So we've got calls out to some of our brilliant organochemist folks to see if they can help us decipher, what's happening with phosphorus in our soils, that they're leaching phosphorus into groundwater. All parameters are highest in septic communities except for the inorganic nitrogen concentrations, which was highest in reclaimed. And I contend that if you live in a reclaimed community, you do not need to fertilize your lawn. You're spraying all kinds of biologically available nitrogen on your lawn every time you turn on your irrigation system. And there's really no need to add additional fertilizer. It's just going to leach out. Your plants can only take so much. You're either going to burn your plants or it's going to just be wasted money. Especially, I'm sure a lot of those reclaimed communities are homeowner association property managed. And if you can save yourselves money on your lawn care by telling them they don't need to apply fertilizer, then you can do something else fun with your money. Maybe have a party after the COVID is over. Some of the Seward communities are contributing to groundwater pollution, and Turkey Creek in particular has twice as much of the TN and TP as the others. So, one thing the study did illuminate was Turkey Creek is an issue with its sewer system that, it's undeniable. So hopefully there'll be some investigation and some effort to reline those sewer lines to address, whatever there is leaking. We certainly, bottom line, no brainer is the groundwater can be a significant source of nutrients in all types of communities. It was only those natural areas that, had very, insignificant amounts of nutrients in them. As soon as you put people on the landscape, those numbers started to double, triple, and quadruple. So, all the communities are contributing to nutrient contamination in our groundwater that is leaching eventually into the Indian River Lagoon. Wanted to give you a little bit of an update. This slide, we got some information from Brevard County on some of the great projects that they're implementing through our Save Our Indian River Lagoon project plan, through our sales tax that we passed here in 2017. The top of the table are the reclaimed wastewater treatment plant upgrades that they are planning to do. So fortunately, Palm Bay, the most contaminated reclaimed community was in Palm Bay, and it is in the progress of being reconstructed to improve I guess to decrease the discharge of nutrients in their discharge water. So for example, some wastewater treatment plants are discharging 3 milligrams per liter, like City of Cocoa Beach has a improved wastewater treatment plant where they're doing tertiary treatment, it's called, and they're putting out 3 milligrams per liter. We took a sample of Palm Bay's irrigation water. This came out of an irrigation line and it was 28 milligrams per liter. So getting that amount of nitrogen reduced down to 3 or 6 or anything less than 28 would be great. So that's what they're working towards, you know, getting that wastewater treatment plant upgraded so that it's going to be spraying less nitrogen and phosphorus all over everybody's lawn. Although I still contend you don't need to fertilize. The other one is the Titusville one, was that second one that was so high. It's in progress. They've gone through the design and permitting and it's out to bid for construction. So it's on its way. The other project type is that septic to sewer conversion. So these are people, communities that are on septic tanks that are given an opportunity to have their homes hooked up to the sanitary sewer. So there are 3 in the works through the soil plan. One in Suntree is in progress and the permitting is finished and it's going to be, construction should be starting this summer or early fall. Marin Island, it's being redesigned. The construction start date, you know, who knows, are proposing summer 2022. And then the Turkey Creek septic community is has not started yet. So we're planning to continue groundwater monitoring as, you know, as long as this is helpful and as long as the county will fund it, of course, to evaluate the effectiveness of these projects. So as projects are being completed, you know, we continue monitoring, we should see and be able to calculate what the resulting reduction is, not only of the nutrients going into the groundwater in that community, but ultimately the nutrients that are loading into the Indian River Lagoon from groundwater as these projects are being put into play. So there's no easy answer. It's always, you know, it can't just be septic, you know, it has to be septic and leaking sewer lines and wastewater treatment plants. And, you know, like, you know, we have an and problem, not an or problem. We've got a problem, you know, with the lagoon that it's just, you have to do it all. We got to do everything. That's all I got. Thank you all for your interest and your attention. Happy to answer any questions. And I don't know where we are. Thank you. And a shout out to my friend and colleague, Claudia Listapad, Applied Ecology. If you need good environmental work done, look her up.
Awesome. Thank you so much, Dr. Leesa Souto. That was a fantastic presentation. We do have quite a few questions being submitted through the Q&A, but before we get started on those, just a couple of friendly reminders that this presentation is being recorded along with the Q&A session. So if you need to jump off at any time, this presentation will be uploaded to our YouTube channel later this afternoon and on our website in the coming days. And additionally, we'll be answering the questions first submitted through email. We'll be addressing the groundwater questions specifically to this program first. And then if we have additional time, we will answer any questions about the Indian River Lagoon. Okay, awesome. So our first questions that were submitted through email, and here's the question. Does the quantity and type of minerals and/or salts vary depending upon the depth in the water column in regards to groundwater? And what effect would that have on using groundwater for irrigation? So basically, does soil have an impact on groundwater irrigation?
Yeah, I don't know. No. Okay, so salt. So I was a little confused. So in the groundwater, it's fresh water. There's we do a conductivity meter in the wells. We don't do a vertical profile in the wells. So I don't know. I don't remember the question. It was something about salt in the wells and
water column, and what effect does it have? Do salts have effect on rainwater for irrigation?
okay. Yeah, no, we're not doing that. So as far as irrigation, yeah, it would definitely, so if wherever you live, if you are thinking about using your well for irrigation and you don't know what your well, how salty your water is, you might want to get that tested. If that's where the question is coming from, because there are certain areas where we've got saltwater intrusion, not in our study, but there are areas in the county where there's saltwater intrusion, which is going to get worse, of course, with sea level rise, and you don't want to kill your grass.
Well, I agree. And, and this is a second emailed question, and it does kind of relate to what you just touched on. What implications does this work, the groundwater study, especially beachside, have when we considered projected sea level rise? Will we be in a similar position to Miami with a pressure head of sea water infiltrating our groundwater?
Yes. So I got the, will we be in a similar situation where we've got head pressure from seawater? Yes, of course we will. We've got sea level rise coming. So what's interesting is that a lot of people focus sea level rise on the barrier island when it's actually going to be Merritt Island that goes down first. It's going to come up the lagoon. You can go to the NOAA Sea Level Rise website and watch this happen. It's kind of exciting. And it's going to actually affect people lagoon side first. And it's going to go right up the middle of Merritt Island, open up Sykes Creek, almost divide Merritt Island in half. So all of that super low bowl, that's the middle of Merritt Island, where guess what? We're still putting septic tanks, by the way, is going to be flooded. So what this is telling us, and it's really, I think, just reiterating the obvious, that if a septic tank is sitting in the water, it's not treating anything. It's just discharging raw sewage into the groundwater, okay? There's not enough time for any of that to be broken down because it's just sitting in the water. So yes, as groundwater elevations rise to hit those septic tanks, we're gonna have more and more and more of a problem with nutrients in groundwater. And by the way, all those leaking sewer lines, which are also going to start to be submerged. So what, can I go ahead on my spiel about? So what happens with some of the spills that happen with big rain events, and these wastewater treatment facilities are permitted to discharge during high rain events. They are permitted to, they're allowed to. So if there's a heavy rain event, and the water starts to percolate down into our groundwater. The groundwater starts to come up. It hits everybody's septic tank. It also hits the sewer lines. If those sewer lines are permeated in any way, shape, or form, the water that's now in, that they're submerged in is going into the sewer line. So when the water's low, when the groundwater's low, the sewer lines are probably leaking a little bit. But when those sewer lines are cracked and they're submerged, that water's rushing into the sewer line, and it's rushing down the sewer line to the plant. And if it hits the plant, it's going to kill the plant for one thing. All those bugs and bacteria in that plant are stabilized at the perfect level. And if it gets all of that stormwater, it's going to mess up those bugs and that activity. First. Second thing, if that plant can't handle that water, it's going to back up and discharge into everybody's house that's on that sewer line. So they don't want to do that. Obviously, we don't want them to do that. So they have to discharge. They have to figure out, what do we do with these hundreds of millions of gallons of stormwater that just rushed into our plant during Hurricane Faye or whatever? They have to discharge it somewhere. Those are permitted discharges. So again, this high water, groundwater coming up is not only a septic tank problem, it's a sewer line problem. And it's really just it's going to shorten the time between whatever's on the surface and an already shallow groundwater aquifer. So the less time there is between the top of the land and when whatever it is trickles through the sand to hit that groundwater, the less chance of anything nitrifying, denitrifying, or being taken up in any other way. So yes.
Sorry about that. So we have two quick questions. What is the total well depth used in the study? And you mentioned that there was a 10-foot screened well. Is that the total depth of the well?
Yay, an easy question. We used screen interval of 10 foot. We tried to encompass at least 2 feet of the water table. I don't think any of them are more than 30 feet deep. I think I'm trying to think of one of our natural areas, the Enchanted Forest. I think we went down to 32 feet. So then the screen interval would have been from 22 to 32. But most of them, we barely had 2 foot of riser, meaning that the screen interval started at 2 foot below the land surface and went down 10 feet. So we were trying to encompass the surface, provide enough area for the up and down of the groundwater. And so that's how that went. So it varied. So pretty much saying either total depth went from 12 feet to 32 feet, depending on the site.
Okay, so our next question is, I use composting on my garden. Is that going to affect the nitrogen levels in my groundwater?
Thank you for using compost. That's awesome. Is it going to affect the groundwater? I don't know where your groundwater is located. So compost is it's harder to break down. It's going to sit there and cultivate your soil and create bacteria that are going to naturally break it down and make it into a form that's usable for your plants. So organic compost, unless you're putting several feet of compost, it should be fine. It should be that you're turning it over with your soil. It's enriching your soil. Unless you put it down and we get a deluge of rain, that would be, a chance where it would leach through and a bunch of it would get into groundwater. I don't know where your depth of groundwater is. So, so it's possible. It's not probable. Probably not. It's probably not going to be a big impact on your groundwater.
Awesome, thank you. Cool. All right, so this is another kind of general question about the groundwater study. Did you take into consideration the time factor, i.e. empty residence during the summer when snowbirds are not here?
Did we take into, so we just went and collected samples and then looked to see where the differences were and didn't see any difference in like a regular seasonal pattern of variation.
Okay, I like this question. Do backyard chickens have an impact on nutrient levels in groundwater?
Okay, who asked the chicken question? So again, just like the compost question, it kind of depends on how many chickens you have and where your depth of groundwater is, and how much it's accumulating. So I don't know how to answer that one. It depends on where you are, and again, if it is an organic material, it's going to come with its own breakdown bacteria. So it comes as kind of its own package of all the stuff it needs to break itself into something usable for plants to take it up. Ultimately, the way you get nitrogen and phosphorus out of water is to put a plant in it. The plant will take it up. It will use the nitrogen and phosphorus to create its leaves and all of its tissues. And then now the nitrogen and phosphorus are in the plant. If you leave the plant in the water to die, the nitrogen and phosphorus go down back in the water again. So if you're using compost or chicken manure for your garden, you're harvesting your plants. At the end, you're either removing your plant material or you're rototilling it back into the soil again, where it's creating more compost. When you think about the water column and how we have been dealing with aquatic weeds in Florida, there has been a change in our method of handling weeds in the past 10 years. We've gone from using a lot more mechanical or hand harvesting, where you've got personnel out on a machine or a person out there pulling cattails, which is what we always had to do on the farm, to broadcast herbicide spraying, which was cheaper. So when the administrative change happened about, 14 years ago, they reduced costs, and this was during, we were having a financial crisis at the time, so maybe justified, but could have ended up being a disaster. Reduced costs, laid off 1,100, state employees, including all those hand pulling people and harvester people, and started broadcast spraying. Broadcast spraying, besides putting herbicide in the water, is also killing plants that are then decomposing in the water. So all those canals filled with hyacinth, all of that stuff, where does it end up? Flowing to the coast and landing in our lagoon, where it sits there and rots, turns into muck. So there's so many moving parts. There's so many places. It can come from everywhere. But I appreciate your concern and your questions about using compost and using chicken manure and so on in your yards. I don't want to discourage you, because that's the right way to fertilize your garden and your yard. Not the wrong way is to put chemicals that are just like nitrate, ammonium nitrate. Let's put liquid ammonium nitrate all over our lawn. Then ask the question, is this going to hit our groundwater? Yes, it is. So, I don't want to discourage using organic fertilizers. I do want to discourage using chemical fertilizers. So just stop fertilizing your lawn with chemicals.
All right, thank you very much, Lisa, for that. All right, so we have got a lot of really good questions. So I'm not sure if we'll be able to get to any of the specifically Indian River Lagoon questions, because we do have a lot of questions specifically about groundwater and about this groundwater study, but we are definitely going to do the best that we can. Can the reclaimed water be scrubbed before being distributed to communities without moving it to the clean water category?
Yes, it can. So it can, we have tertiary treatment is available. And there are even tertiary treatment, it's like the third step of treatment that wastewater treatment plants can use. And it's old now. So tertiary treatment is now like the old way of doing things. I mean, there are like these amazing new wastewater treatment innovations that are coming that it would be great if we could get some of those here. And I know that actually our dear friend, Senator Mayfield, has been trying to get a pilot somewhere in the lagoon area of a wastewater, one of these brand new state-of-the-art wastewater treatment facilities, kind of as a showcase, to show what wastewater treatment plants can be. They cost a lot of money. Well, all wastewater treatment plants are in the tens of millions of dollars. So hopefully, we can get one of these really innovative, nifty new wastewater treatment plants that emit zero nitrogen, zero. But the tertiary treatment usually gets it down to about 3. So 3 milligrams per liter. You still don't want to drink it. I mean, I didn't even talk about bacteria today, right? So we also did bacterial testing. We did isotope testing. There's bacteria breakthrough a lot also with that irrigation water. So that, seriously take those non-potable signs seriously. You don't want to touch it. You don't want to drink it. You don't want to get it on your skin, especially knowing what's in the waste stream now. You don't want to risk it. So those fountains that are on non-potable reclaimed water when on a windy day like this, don't go anywhere near those. But yeah, I think I went astray on that answer.
Sorry, yeah. we have another question. And this is, could the high values of nitrogen from reuse or reclaimed water be from people overwatering their landscapes?
I think that's a really good question. So asking about the overwatering. It depends on, so the community that we happen to be in, the HOA turns on and off everybody's irrigation. So the individuals don't have the choice of when to turn on or off their irrigation system. And so they have one system, and in that case, they were not overwatering. They were in control. There are times of the years, but your question is a good one from the perspective of when you think about wastewater treatment plants and, when is there a lot of water and when is there not a lot of water? And some of it is during the snowbird season. So when there are more people here, there's more wastewater. Now there's more water, we got to get out. They just need to, the irrigation, the reclaimed water is something it's a product they have to get rid of. So if they've got too much of it, they're going to say to the HOA, we need you to get rid of this water. Can you just run it for 8 hours? So from what we know from our HOA, they didn't ever have that occurrence, but we were curious about that. But you can, common sense again, when there's a lot of water they have to get rid of, they're going to be cranking out that reclaimed water. And likewise, when everything dries up in the winter and everybody needs to irrigate their lawns, it's looking a little crunchy, there's not going to be as much water coming out of the reclaim lines because it's the dry season. So yeah, it was a good thought, and we thought of it also, and it's very possibly a variable.
All right. So, I mean, there are fantastic questions. I'm hoping that we can get to them all. So this one relates to the nutrients once they are in the groundwater. So once there's a lot of nutrients in the groundwater, what is the main direction to where the nutrients flow within the groundwater, and if there's any breakdown of the nutrients before entering the lagoon? Does that make sense?
That's a great question. So yes, and that's kind of one of the complications, and we're continuing to follow what we call kind of the plume. So where for example, we assume a source. We are working in communities, and we've got our wells installed to intercept pretty much a community's flow to the lagoon. We ran models initially to understand the flow dynamics of the community, and then we placed our wells along the lines of those flow dynamics. So we have a pretty good idea of the flow, the direction. The question about, how much does it nitrify or denitrify before it reaches the receiving water body is a great question. And that's where we wanted to head next. We did a pilot project with Brevard County again, applied ecology. And we put what we call seepage meters into Turkey Creek to try to understand what's seeping from the bottom in groundwater, seeping through the bottom of Turkey Creek. A better understanding of how much of this nitrogen we're seeing in groundwater are we seeing in Turkey Creek that's coming in through seepage. So we started investigating that. We found that the levels were really high coming in through seepage. Seepage could be coming from way deeper than where we're measuring groundwater. So it's a very complicated giant sponge called our aquifer. And when you're looking at seepage coming up, you don't know where all of that seepage is coming from. It could be coming from dozens of feet down. It could be coming in laterally. It could, so it is, it's interesting. What we found in Turkey Creek was that it actually goes both ways. Certain times of the year, it's negative seepage. It's actually going down, and then other times it's coming up. So just that dynamic is going to change, the nutrient concentrations in Turkey Creek. Is the water going from Turkey Creek into the ground, or is it coming from the ground into Turkey Creek? That changes from month to month. So super interesting question, not an easy one to answer. We're trying to investigate that.
I think we're okay. I clicked something and it moved. Oh, that was scary. All right. Has there been any attempt to get at the natural background nutrient concentrations for the beaches area? Perhaps Cape Canaveral National Seashore might be a good candidate since it is in a natural state.
Yeah, we have a control area over in the beaches. It's actually in one of the eel properties. And that was one of the, I didn't show when I did the breakdown of the different community types, I didn't include natural because there wasn't a lot of difference in them, but the beaches natural has the same high phosphorus that we saw on the beaches for everything, which that's where we got our hypothesis that the phosphorus could be naturally occurring. It could just be an artifact of the beach's sands. But yeah, we have control wells, 2 control wells out at, I think it's Coconut Point, the Environmentally Endangered Lands Sanctuary there at Coconut Point.
And Leesa said that she thinks those locations are also deep wells as well. So we're getting close to kind of getting to that kind of hybrid of groundwater and lagoon questions. But our last kind of groundwater question is when and if will the bacteria and isotope data be available?
Bacteria and isotope data are available now. You can email me at that email address and I'll send you the report.
Awesome, thank you. Okay, so now we're kind of in that mix between we're going to the next level of questions. Okay, since septic systems are so polluting and it is so expensive to change over, is there anything that can be done to reduce the cost of conversion from septic to sewer?
Looks like, or like why are another question was why are septic systems even, especially in beach areas?
Okay, now I got two questions. Why are septic? Why septic tanks? That's a darn good question. Well, because we are a pro-development state and we can't keep up with our wastewater treatment services. And so it defers the cost of impact to the developer and obviously the homeowner who's going to have to incur the cost of the home with the septic tank in lieu of the city or county actually having to come up with the money to put in another wastewater treatment plant. So let's let as many people in as possible and get them on the ground as quickly as we possibly can. So who cares if their septic tank is sitting in groundwater? There's the answer to that one. What was the other question?
Why are septic tanks
Oh, I just answered that. Oh, how to make it less expensive? Yeah, no. So the cost for hooking up to sanitary sewer, if you're the homeowner, it's going to be related to how far your house is from the road, because you have to run that lateral line. The lateral line is the line that goes from your house to the city or municipal septic, the sewer line. So the lateral line is our responsibility as a homeowner. And we're responsible. So I have one. I live in downtown. I have a 70-year-old house, and I'm worried about my lateral line. So it's as far as reducing cost, the way I'm going about it is, I'm going to pay $250 to have some guy come in and scope my lateral line and give me an idea of where we're at. So I know when do I need to replace this thing. Then it goes on my budget as another maintenance item along with roof and my shed that's going to fall apart at some point, and these other things I'm going to have to spend thousands of dollars on. And depending on what he tells me after his $250 assessment, I'll know where that's going to land on my list of priorities of what I'm saving up for next. So, how do you reduce the cost of that? I think you try to lobby your city or county representative to give you a grant, and some cities are doing that. If you're in Satellite Beach, I think there already are replacing people's laterals. If you want to contact City of Satellite Beach, they were doing that. I'm not sure that program is still available. And there are things, if you're on a septic tank now, you can try using an additive to try to reduce the maintenance cost of your septic tank. Like BioWish. We used BioWish in our study. We did not see a significant difference, but we didn't really have the right study design to see a significant difference. But the homeowners are really happy with the product, and they felt like it was maintaining their septic tanks well. So I don't know if that answers your question. I think there's too many variables associated with the cost of hooking an individual's home up to sanitary sewer. So it would be hard to answer it just kind of like across the board.
Okay, so the next question is there any way to calculate how much sewage waste may remain in the groundwater around Sandpoint Park ponds after 7.2 million gallons leaked out and caused the fish kill in 2 ponds? Is it possible to test the groundwater and measure the contamination?
And horrible occurrence, horrible incident. And yes, I'm sure some of that. I don't know if those ponds are lined or not. Eesh. But
Okay, so this is kind of like another estimate question. How much do golf courses, especially those near the lagoon, pollute with fertilizers?
I think that's a great question. No, I don't know. Nobody's done a really good in-depth study of sources in the lagoon. So it's hard to say how much is coming from. It's going to depend, right? You got to love that. I'm an ecologist. I say it depends a lot because it really does. So it depends on where they're located. It depends on what type of grass they have. It depends on what kind of soil they have. It depends on how frequently and when they're fertilizing, what kind of fertilizer they're using. There is I think it's Florida Department of Environmental Protection's Green Industries Best Management Practices for Golf Courses book that we know Aquarina uses, and that's the only reason that we affiliate with them. City of Cocoa Beach uses. I would like to think all municipal golf courses are complying with DEP's best management practices for golf course management. But it's really hard to say. Somebody would have to fund us a study to go and answer the question, and then we would know. But it's definitely an empirical question that could be investigated. It's just a matter of a priority and what people want to, where we're going to focus our funding first.
Okay, next question. For the Palm Bay data, especially those that showed the linear increase of phosphorus, do you have groundwater level data, if that makes sense? And then did groundwater level increase and stay high during that second half of your measurement period?
No, that's an excellent question. Yeah, we took water elevation. So when we were doing our predictive modeling, and this was from the beginning, before we even started seeing that trend, we have been looking at groundwater elevation in the wells as a predictor of certain concentration changes and so on. And, but that trend, so yes, so that's where you get this up and down like this, but you don't get this up and down like this because the groundwater didn't go up over 14 months and stay up, right? So that's where you get kind of this kind of stuff where it rains, water fills up, goes back down again, you get a spike. So we're looking at a lot. I mean, it's a valid point, and we are collecting groundwater elevation data and rainfall data from as many proximal locations as possible. We even installed a rain gauge in one of our communities because there wasn't a rain gauge close enough for our purposes. But yeah, rainfall is going to be a big player here. So it's a good thought. And we didn't see it as a significant predictor in phosphorus at the long term.
Awesome, thank you. So are there City of Palm Bay officials receptive to the results regarding Turkey Creek?
I haven't talked to, are there any Palm Bay City officials on the meeting today? We can find out. So I haven't had a personal interaction with the city to answer that. I know that they're working closely with Brevard County. They've got soil money, they've got soil projects approved, and that they're moving forward with the wastewater treatment plant upgrades, and hopefully, the septic tanks to sewer as well. So they are in contact with the county. I have not personally had a chance to speak with them about these results. I'm sure they would be. We're in Palm Bay. They're our partners, and we work closely.
All right. I think this is an interesting question. Has anyone looked into utilizing composting toilets? Could these possibly replace septic tank systems?
I want a composting toilet. So has anybody looked into it? I have. I want one for our greenway down at Sebastian. So I'm not sure. I'm not sure what you're suggesting. If I understand correctly, has the county considered giving people composting toilets instead of hooking them up to sanitary sewer? I think that would be a logistics nightmare. I'm not sure. I mean, not that hooking people up to sanitary sewer isn't a logistics nightmare, because that certainly is. I've not heard of anybody locally incentivizing or encouraging composting toilets. I would love that, because like I said, I want one. But you know what, I'm going to write it down and see if there have been any of those programs in the world of trying to incentivize homeowner adoption of composting toilets. I mean, we've done it with shower heads. We've done it with the low flow toilets, you know, where the city of Melbourne, for example, gave a credit for installing a low flow toilet some years ago. So maybe, you know, somebody's done something like that. I'm not sure.
Definitely something interesting to look into. You know, that is an alternative thought. Yeah. So do all forms of nitrogen equally stimulate algae blooms?
No, they don't. And it's actually, we think it's the ortho-P that might be the biggest stimulator, to use your word, of algae blooms. Nitrate is the one. So it's those kind of biologically available. Nitrate and the orthophosphate, which is biologically available, are going to be the forms of nutrients that algae are going to prefer. The different species, so we've got all these different, you know, species of algae now, are going to prefer different things.
Thank you. That was great. Does Brevard County inject treated wastewater into groundwater like some other Florida counties?
So I don't know if the county does. They probably do. There are a lot of cities that do. So yes, people do, cities do. And I want to go back to that previous question, because ammonium, which is coming out of muck, that's the one that the brown tide likes the best. So ammonium is another form of nitrogen that algae like. But as far as you know, advanced treatment and then putting things down, storage and retrieval wells, there are numerous cities that are doing that currently.
This is an interesting question. There's a lot of talk about how, there is a lot of talk about storing carbon underground to mitigate climate change. Does that fit into the groundwater study?
I don't know anything about that. I thought that's where we got it. How do you put it back? You know how to put carbon back underground again?
Me personally, it can be done.
You have to tell me how to do that. No, it has nothing to do with our study. We're really not looking at carbon as an issue, other than that it's going to cause temperature increases and sea level expansion. That's going to hit our groundwater and make our elevations go up. But no, and I'm really curious, how do you put carbon back in the ground again? Cool. Is he just putting the gas? He's putting CO2 back in the ground again?
Definitely something for us to look more into. Another question, can regenerative agriculture play a role in cleaning up the lagoon? Whoever submitted that question, if you're still on the webinar, if you could please explain what regenerative agriculture is. If not, we have, let's see. There are a lot of measures in place to restore the Indian River Lagoon. Which do you think is the most effective in the short term?
Oops, I just did something.
You're muted.
Okay. So stop fertilizing. I think that's the short term. thing to do. No, probably to make the biggest impact in the short term, the thing to do is get the muck out. Get the muck out. It's a process. It takes a year, you get it done, and now you've a clean bottom. You're not emitting all of this ammonium, which is what muck off gases, the ammonium that the brown tide loves. You've got sand for seagrasses to grow back. You've got a place for clams and to settle. So the immediate return, it's a huge investment, but it's an immediate return is muck removal.
Yeah. Okay, so is the St. Johns River Water Management District going to start holding permittees to their permitted consumptive use quantities?
I misunderstood. I thought it was a question about wastewater treatment discharge permits, but it's about consumptive use permits. I don't have any knowledge of consumptive use permits in St. John's permitting of them, except that they gave Coca-Cola a whole bunch of our springs, I guess. But no, I'm sorry. I thought it was about wastewater discharge permitting, which I can answer. Senator Mayfield's Clean Waterways Act that passed and was approved by our governor includes increasing fines for wastewater discharges. If it's the first step really since, I want to say 1996, that anybody has made towards closing the hole, that loophole, which allows certain types of wastewater direct discharges into the lagoon. So just, we have come a long way. We've come a long way. We used to discharge billions of gallons of raw sewage into the lagoon untreated. So now it's at least sort of treated, unless it's just a sewer line break like that just happened in Titusville, where 7.2 million gallons of raw sewage are more or less ending up in the lagoon because those poor retention ponds that it's getting pumped into are not handling it. So we have come a long way from just discharging raw sewage for the most part into the lagoon. And we just passed a bill last year in Tallahassee in legislative session that's going to ratchet down the fines for those breaks and those other types of discharges that are not allowed, that are not permitted, so that those entities are going to be getting nailed with much, much higher fines now as we move forward. That hopefully will create a incentive for municipalities to focus their taxes on improving the existing wastewater infrastructure that exists, maintaining what you have instead of just building new. So let's not pretend that this out of sight, out of mind mentality of let's just bring them in, get as many people into Florida as possible, many people as we can, wherever we can put them in a box and treat their sewage. The focus of our tax, our really small tax money, has been on building new. Nobody's looking back. Nobody's looking at maintenance. Nobody's prioritizing where our sewer lines probably going to start leaking. What's going to be our protocol for identifying, prioritizing, and addressing our existing failing infrastructure? That's what needs to happen.
All right, awesome. Well, thank you so much, Dr. Leesa Souto. That was a fantastic presentation, and especially thank you for going extra long for talking about the different questions, or answering all the different questions that we had. So thank you all to the participants that are still on the webinar. I'm sorry we can't get to the rest of the questions, but we have gone over time today. If you have any additional questions, please feel free to email us and we'll do our best to answer them. Thank you so much again and have a great rest of your day.